Alright, this is Coach Williams. I am going to just run over a few things briefly for the test that is tomorrow for our calculus kiddos. The several rules that we're dealing with right now is the constant rule, the power rule, the quotient rule, etc., etc. These are pretty simple, and I think we've got a pretty good grasp on those. I just wanted to touch base with those a little bit. The constant rule, anytime y equals a constant, let's just say y equals 4, or you may see it as f of x equals 4. Well, the derivative of that is always going to be 0. So f prime would be 0, or y prime is going to be 0. We pretty well have a grasp on that and know that. The power rule, we know if f of x is equal to x to the n, then f prime of x is going to equal n times x to the n minus 1. That's in our notes, and we know that. An example of that would be if we had f of x equal to, let's just say 3x squared. Then we know that f prime of x is going to equal 6x to the first power, to the 1 power. This 2 minus 1, so that would be the derivative of that according to the power rule. Quotient rule, we kind of have this little saying that we've been using. Let's just say that f of x equals, let's do it this way. Let's say we've got low and high. Whatever function's on the bottom, whatever function on the top, we'll call it low and high, because our little saying goes like this. The derivative of x will be low derivative of high. So we have the low, we call it d high. So we'll derivative of high, right? Minus high times the derivative of the low, right? All over low, low, or low squared. Example of this would be if f of x was equal to x squared plus 4 over x, then we would have the derivative. The original function was this, and the derivative would be low function times the derivative of the high function, which would be 2x, using the power rule, minus the high function times the derivative of the low, which in this case is just 1, all over the low squared. If we simplified that down, f prime of x would end up being 2x squared minus x squared minus 4 all over x squared. These would combine to be x squared minus 4 all over x squared, and we'll just leave it at that. So that would be your f prime x according to the quotient rule. Okay, that is some of the rules that we've talked about. Some other things that we have also discussed is linear approximations, tangent lines, and normal lines. When we talk about, we'll just kind of separate this out here. When we talk about the tangent line, we know that that is just using our derivative to find the slope, and we can take a point and that slope and create the equation for the tangent line. And then if we want to create the normal line, then we know that it is just perpendicular to the tangent line. So that means we will take the slope, so we'll just say the slope here would be, let's do it this way, would be negative 1 over the slope, or you could say it is the opposite reciprocal. Opposite reciprocal, the slopes would be opposite reciprocals of each other. So whenever you find for the tangent line slope, for the slope of the tangent line, you would just take that, flip it over, and change the sign to write the equation for the normal line. And you could use the exact same point whenever you create your equation. We will write that equation, and we can leave it in the form of y minus y1 equals m times x minus x1, which is a point slope form, and that is sufficient. Unless they request it in a different format, this would work and be acceptable. Linear approximation. When we talk about linear approximation, let's just have an example here. Let's say that f of x was equal to 2x squared plus 6, we'll say. And we wanted to approximate, let's say we wanted to approximate 2.97. So we wanted to find out, what it would be if we use 2.97. Well, instead we'll use 3 to set our equation up, and then we'll evaluate the 2.97 in the very end. First thing we're going to need to do is we're going to use 3, so we need to find the point value. So we'll take 3, plug it into the original equation. 3 squared will be 9, 2 times 9 is 18, plus 6 will be 24. So the value of the point will be 3 and 24, the ordered pair. Then I need to go and find the derivative, which in this case is pretty easy. It's just going to be 4x. I can plug the 3 in to find the actual slope. We want to write that out here. This is the slope, the formula to find the slope, or equation for the slope. So if I find f prime 3, 4 times 3, which is 12. So that is my slope. Here's my point. Together, I can create the equation. We can say it's y minus 24 equals 12 times x minus 3. And if I simplify this down, or I don't even really have to, but I will get y by itself, we'll say it's y equals, we'll go ahead and distribute this in. This is going to be 12x minus 36, but we moved the 24 across, so that's going to be plus 24. We will have y equals 12x minus 12. Okay, and at this point we would then say, okay, well, let's evaluate this at 2.97. So we would have 12 times 2.97 minus 12, and at this point we would just take 12 times 2.97. If we do that in the calculator here, 12 times 2.97, and we minus 12 from that, we're going to get 2364. So the value would be 2364, f of 2.97, and that would be our value using linear approximation. We would also, look at this and say, okay, well, was the approximation high or low? According to the original function, this is a squared function, so we're going to have a parabola. It's also positive, so we have a parabola pointing upwards. We're evaluating at 3, so we're in any case, we're going to have a graph that's going to be, our tangent line is going to be below this curve, so our approximation will be low, because it is below the curve. Okay, so it's below the curve. And then there's some other examples we did in class with trig, and we won't get into all that at this point. Trigonometric identities will be given for the test for tomorrow, so you can use those. And you'll be able to plug those in. Also, you'll use your unit circle to find out values whenever you do have points for sine of, say pi over 4 or pi of thirds or whatever it may be. So you'll be able to use your unit circle, and you'll be able to use your trig identities to solve for those. Oh, I tell you what, we had also the product rule. I'll add that in right here at the top. I forgot to mention that one too. the product rule was the plus one. We always said that was the plus one. That's real easy. It's a little bit more difficult to get that one, out of sorts because it's addition and multiplication, which are commutative. So the order doesn't really matter. But let's say that f of x was equal to x squared times x plus 3, or maybe make it 2x plus 3. Let's do that. Then I would have to, by the product rule, take the first one times the derivative of the second one, add the second one times the derivative of the first one. Okay? And then if we simplified that down, we would have 2x squared here. Then we multiply this in, we would have plus 4x squared plus 6x. We could combine those together. We would end up with 6x squared plus 6x. And that would be your product rule applied here for this function. Okay, hopefully you can see all through the hen scratch. Again, this is just kind of a notes for some of the kiddos that were wanting to get a little quick review on some things. Hopefully this has helped you out, and we will see you guys tomorrow.